Loeb teamed up with the Pentagon office that investigates unidentified aerial phenomenon, and they released this draft report that indicates it is possible that alien ships have already visited our solar system.
Several celestial bodies have been found in and around our solar system. But recently, an unexpected visitor has arrived again. After being introduced into our solar system from beyond the stars in late 2017 and got astronomers around the globe captivated, Oumuamua is here again. What can we expect? What is its significance, and what more can we find out about it? Watch this video to the end to get the answers to all your questions. Compared to the universe and all of space, humans and our planet Earth make up only a small percentage, which is why we have been trying to explore space for years. We've tried to explore from the Earth with high-powered telescopes that can see far into space and enlarge objects too far off for our eyes to see. When that was not enough, the use of space telescopes became a thing. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope, JWST. The purpose of such telescopes is to observe and gather data from outer space. These telescopes are designed to overcome the limitations and obstacles that telescopes face on Earth, such as atmospheric disturbance. In this space, strange objects or perhaps visitors lurk around. Since the telescopes were launched, they have revealed a lot of amazing discoveries in space, including an image of a giant space object and a visitor from afar. The Oumuamua. Oumuamua is an interstellar and bizarre visitor that has made its way through our solar system, originating from another star system, and was discovered by astronomer Robert Weirich on October 19, 2017. The discovery was made by the Pan-STARRS telescope at the Haleakala Observatory, Hawaii. The Pan-STARRS telescope is an Earth-based telescope created to discover Earth-approaching objects that may or may not cause harm. The telescope is designed to detect and document astronomical objects such as asteroids and comets. It possesses a 1.8-meter mirror designed to view objects in the visible and infrared wavelengths of light, offering an expansive view of space and celestial objects. The telescope scanned through distant galaxies, nebula, elusive comets, and asteroids. During the survey, a colossal amount of data was collected, which the telescope processed using the PS1 Imaging Processing Pipeline, IPP. It uses advanced algorithms and machine learning techniques to analyze and classify objects in the images rapidly. It also identifies celestial bodies, using the resulting dataset as a valuable resource for astronomers working to understand the universe and its origin. Since its discovery, it has sparked much controversy and interest among scientists due to its mysterious characteristics and origins. Oumuamua is long, unique in shape and size, and around 800 meters long, about 35 to 167 meters wide, resembling a cigar or a pancake. The strange shape and acceleration of the object made it evident that it was not from our solar system. It resembled a slim cigar, also called the cosmic needle. Scientists recognize the strange object as the first known interstellar object to visit our solar system. And it was such a monumental discovery because the object is believed to have originated outside of our solar system. And it was fascinating that it made its way into the solar system without hindrances or being sucked in by the sun. What has made the Oumuamua the point of attention to astronomers? Many things about the object seem strange, from its distant red color to its weird behavior and shape to its speed and random movement. These qualities of the object made it popular among scientists and astronomers. Oumuamua has an elongated and highly unusual shape, resembling a cigar or a pancake. Most asteroids or comets found in our solar system have irregular or rounded shapes. Oumuamua looked like an elongated structure, a space cigar, and its size was equally shocking, having a radius of approximately 200 meters and a length 10 times greater than its width. These measurements are quite exceptional to be found within our solar system. Our mind imagines a round or somewhat spherical object when thinking of most celestial bodies in space, and most tend to adopt spherical shapes due to the gravitational forces at play. Within an object, the atoms are typically attracted to a single gravitational pull, keeping the atoms compact and spherical. Although the exact cause of Oumuamua's shape is still unknown, some possible explanations have been suggested. One is that it was formed through interactions with other objects in interstellar space, such as collisions or gravitational encounters. It may also result from a planetary formation process, where it could have been formed in a different star system before being ejected into interstellar space. Another possible explanation is that it could have been formed through another unknown process. Whatever the cause, Oumuamua's shape has added to its mysterious nature and has sparked much curiosity among scientists. Oumuamua was also observed tumbling and rotating irregularly, uncommon for small solar objects. The erratic rotation adds to its mysterious nature. Various theories were proposed. It has been theorized that gravitational forces from other stars could have caused the object to spin and tumble erratically. Another possible explanation is the object was once part of a binary system containing two objects orbiting each other, and the other object got ejected from the system, causing Oumuamua, the remaining object, to experience a tugging force which could amount for its tumbling motion. Part of the motion observed of Oumuamua is the non-gravitational acceleration it exhibited, possibly due to outgassing or a push from solar radiation pressure. Oumuamua had an unexpectedly high acceleration away from the Sun, which implies that a gravitational force may have been acting on it, which could indicate it originated from outside the solar system. Some astronomers suggest that it came from the constellation Lira, about 600 light-years away. It passed through the solar system on September 9, 2017, moving at a speed of 196,000 miles per hour, 87.3 kilometers per second, and is now on its way back out of the solar system. Another strange feature of Oumuamua is its reflectivity. It is estimated to have a 5 to 10% reflectivity. This means that it reflects only 5 to 10% of the light that hits it, and compared to most comets, asteroids, and other celestial bodies, it is much darker. This low reflectivity could be caused by various factors, including its composition and shape. Its shape is elongated, which causes it to absorb more light than a round object. Additionally, its composition could be made up of dark, low reflectivity materials, such as carbons or silicates. Oumuamua's low reflectivity is an intriguing property that has yet to be fully understood. It is hard to understand many of the object's properties since the exact composition of Oumuamua is still unknown. It is thought to be primarily composed of frozen volatiles, such as water and carbon dioxide. It is also thought to be made up of rocky materials such as iron, magnesium, and silicon. The object may comprise other organic compounds such as amino acids or organic molecules. Even though the object is supposedly made up of these gases and compounds, and its close approach to the Sun, Oumuamua shows no signs of having any visible dust. All researchers could find was a distinctive reddish tint, usually found in objects located in the outer regions of our solar system, and primarily attributed to surrounding dust, which leads to another source of confusion. Because Oumuamua had no traces of dust, it appeared to be composed only of rock and metals. Oumuamua's reddish tint could be due to the presence of carbon-based compound on its surface and in its composition, indicating that it is composed of different materials than other asteroids or comets. When exposed to sunlight, the organic compounds and hydrocarbons on the surface have a dark red hue, likely due to exposure to cosmic radiation, which can cause organic materials to change color over time. Additionally, the object is believed to be an icy comet, and the reddish tint could be due to frozen carbon dioxide, which can create a reddish hue. This coloration could also be the result from a coating of an iron-bearing mineral like magnetite, which can give an object a reddish tint. There is still much debate about the origin of Oumuamua, but its discovery has opened up a new field of study and helped shed light on the history of our solar system. Various and sometimes funny speculations about the object have been put forward by scientists, all in a bid to grab the origin of the object. While some scientists believe it is a comet from an atmosphere, others believe it is an asteroid that has been enlarged by tidal forces and is very old, estimated to be at least 100 million and possibly billions of years old. Some even believe it is a probe sent out by an alien civilization. As funny as it might sound, this is a theory people actually put forward and are seriously considering. The scientists who claim it was a comet did not have much ground to support their claims, because comets have comas and tails, and this object seemed to have lost its coma. In our solar system, a comet only loses its coma when it moves away from the Sun and gets too far away for solar radiation to heat the nucleus, causing the icy material to stop vaporizing. The coma dissipated and this object moved quite close to the Sun, enough to heat its nucleus. The subsequent assumption that it is an enlarged asteroid is also not a great option, and this is because asteroids are gravity-bound, while Oumuamua is quite obviously not under gravity's hold. Astronomer and Harvard professor Avi Loeb suggested the possibility that Oumuamua is an interstellar probe sent by an extraterrestrial civilization, adding that an advanced civilization could have sent the object to explore our solar system. His argument has been met with speculation and sparked a discussion about the possibility of extrasolar life and its implication for humanity. There is no evidence to support his theory. This leaves Oumuamua with other possibilities, so it is unclear if Loeb's argument will ever be proven to know if we have intelligent neighbors on other planets. Several other theories that lack good backing include that the Oumuamua could be a piece of a planet that was destroyed by a collision. It could be a fragment of a comet that was torn apart by the Sun's gravity. It could be a natural satellite that was ejected from its parent planet. It could also be a manufactured object, such as a space probe. As speculations are being made about the nature of Oumuamua, it is worth noting that scientists are also considering the option that Oumuamua is something that we have never seen before. In 2023, two teams of astronomers came together and proposed that the acceleration of Oumuamua could be explained by the release of hydrogen gas from the object's surface. Its acceleration away from the Sun as it passed through our solar system was shocking, even though based on its gravitational interactions with the Sun and other planets, it was not expected to do so. The researchers from the University of Arizona, Jennifer Bergner and Daryl Seligman, proposed the hydrogen gas theory. It has been suggested as a possible explanation for the acceleration of Oumuamua. This hypothesis is based on the idea that Oumuamua is a comet-like object that releases gas as it passes through the solar system. These two researchers suggest that Oumuamua is composed of hydrogen ice formed in interstellar space and is trapped in Oumuamua thanks to millions of years of cosmic radiation. As it passed close to the Sun, the heat from the Sun caused the hydrogen ice to turn directly from solid to gas, a process known as sublimation. This released hydrogen gas would escape from the object's surface, providing a small thrust that could be called the jet engine effect that would cause Oumuamua to move away from the Sun, giving the object a surprising amount of acceleration as it left. If this is the case, the gas released by Oumuamua is likely to be hydrogen, the lightest and most abundant element in the universe. Additionally, the temperature of Oumuamua is lower than that of the Sun, so some of the hydrogen gas released would likely be in a molecular rather than an atomic form. Molecular hydrogen is more effective at producing thrust than the atomic form. The hydrogen gas theory remains one of the most widely accepted theories concerning Oumuamua, and this is because several observations support the hydrogen gas theory. An example is in the object's shape. When observed, Oumuamua was seen to have a very elongated shape, which becomes explainable if it was a sheet of hydrocarbon ice stretched out by the Sun's gravity. To further bolster the point, Oumuamua showed no signs of activity about that of a comet or an asteroid, such as a tail of dust or gas. and this is consistent with the idea that the hydrogen gas theory that Oumuamua is not a comet, but an object composed of hydrogen. Although this theory has many backbones, some things are still duly missing. If indeed the object was accelerating via the escape of hydrogen gas, it leaves a lot to ponder over how the gas could escape the object's surface without it being affected and slowed down by gravity. This question remains unanswered, but irrespective of its shortcomings, this theory, the hydrogen gas theory, is an excellent way to figure out the object's acceleration. Despite all these challenges, is there a way forward? There might have been advances and shortcomings in recent years, but studies and research are continuously undertaken to ensure steady progress in the field. Since the object's discovery, it has been an object of curiosity for astronomers and researchers alike. Therefore, they have been finding ways to get an actual image after it was first sighted. This has yet to prove to be an easy feat, but it has made some headway on the issue after sending the James Webb Space Telescope into space. Unlike Earth-based telescopes, this telescope can view objects farther off without clouds of dust and pollution covering them. Telescopes like the JWST use high-resolution and state-of-the-art high-sensitivity instruments, giving it a unique and outstanding capability to discover and observe objects that are too old, far, or faint for other telescopes to observe. In studying very distant celestial bodies, the JWST has the edge over others, as it is also equipped to gather and analyze data and images using infrared rays. Studying such objects from telescopes on Earth is a tedious and, in many situations, impossible. Studying them properly requires a deep and detailed picture of the object. This is the James Webb Telescope's area of specialty. The telescope has an advanced collection of infrared cameras, near-infrared cameras, and mid-infrared instruments that captures distant objects with more precision and accuracy. With these sophisticated features, the telescope can give a more captivating, precise, and detailed picture of interstellar objects as they shuttle by. Some of the instruments the JWST uses is its mirror. It has a primary mirror consisting of 18 1.32 hexagonal segments that capture various images. If you are not impressed by this, the JWST also possesses a feature that can take multiple tiny images of the parts of the object in question and later put all the tiny pieces together in one piece to create a mega image showing the tiniest details needed, even if you cannot get a complete image at once. With its unique ability to capture the most microscopic details, it was the dawn of a new day for scientists, astronomers, and researchers. They can now conduct otherwise impossible research and uncover the universe's secrets. With this telescope, the tentacles of exploration have been stretched and extended, allowing astronomers to look into space with a more precise line of sight than ever before. Indeed, the Pan-STARRS telescope in Hawaii discovered the first interstellar object. The JWST was preferred over it for further exploration due to its stellar features. A necessary clarification is that it does not mean that the Pan-STARRS telescope is inferior to the JWST. They are simply different. The Pan-STARRS telescope is Earth-based, while the James Webb Space Telescope is in space. As earlier stated, as Oumuamua moves through our solar system, it does so at incredible speeds through our solar system. This is a big challenge to researchers because it gives them only a few days to gather as much information as possible before it travels too far for any instrument to view and capture. The knowledge that any delay could hinder their understanding of this particular object came with more pressure and a desperate need for fast and accurate analysis. Because the object in question was one that no one had ever seen or imagined, the goal was to capture as much data as possible so they could study it later. Once it leaves our solar system, there may not be another opportunity to get the information. So they spent no time bringing in every researcher and every instrument that could gather data for the job. To further optimize their plan, NASA moved to the big leagues to shed light on Oumuamua's characteristics. This started with the decision to bring Chile's Large Telescope operated by the ESO. It is one of the world's largest optical infrared telescopes. The telescope was inaugurated in 1998 and is equipped with various instruments including the Wide Field Imager (WFI) and the Multi-Unit Spectroscopic Explorer (MUSE). The telescope is used for a wide range of astronomical research, creating high detailed images of galaxies and stars, including the search for exoplanets, the study of galaxies and star formation, and the analysis of the large-scale structure of the universe, accurately measuring the object's dimensions and orbit, and analyzing its color and brightness. Some other forms used were solar orbit maneuvers, solar sails, and gravity assist from Jupiter, among others. Solar orbit maneuvers are a maneuvering technique used to explore objects in space. This technique involves using a spacecraft's thrusters to alter its trajectory, allowing it to fly close to an object of interest. In the case of Oumuamua, the Lira mission will use such maneuvers to fly close to the object and collect data on its composition, origin, and other characteristics. Additionally, the spacecraft will attempt to detect any potential signals that may have been emitted by Oumuamua, which could confirm its extrasolar origin. Project Lira is a research project funded by the Breakthrough Initiatives, which seeks to answer whether the mysterious interstellar object Oumuamua is an extraterrestrial spacecraft. The project plans to use the Green Bank Telescope in West Virginia to listen for possible signals that could be coming from Oumuamua, which could confirm its extrasolar origin. The Lira mission will use an array of instruments to analyze Oumuamua in detail. The cameras will provide close-up images of the objects, while the spectrometers will measure its composition, and the other sensors will collect data on its temperature and other physical characteristics. The mission will also explore other interstellar objects passing through our solar system to understand how they form and evolve better. Although the object has passed our solar system, the project is investigating the development of new technologies that could make it possible to catch up to Oumuamua, such as solar sails. Solar sails are a form of spacecraft propulsion that uses the sun's power. Solar sails use the radiation pressure from the sun to push a spacecraft through space, and they work by reflecting the sun's light and thus creating a small force on the sail that propels the spacecraft. The radiation pressure is minimal, so a large sail is needed to generate enough thrust to move a spacecraft. This form of propulsion is very efficient and requires no fuel or propellant. Solar sails can also adjust a spacecraft's course as a supplementary propulsion for larger spacecraft. Solar sails are an exciting propulsion form that could revolutionize future spaceflight. Project Lira's main aim is to assess the feasibility of sending a spacecraft to Oumuamua or 21 Borisov within 5 to 25 years. The only challenge is getting to the asteroid in a reasonable amount of time and at a reasonable distance from Earth. Yet to be able to gain useful scientific information using a gravity assist method from Jupiter to increase the spacecraft's speed. Sending a spacecraft to Oumuamua or 21 Borisov will depend on several factors, including the spacecraft's mass, the distance to the asteroid, and the desired scientific objectives. Although the project is still in its early stages, it already shows the potential to be a groundbreaking mission that will allow us to learn more about the origins of life in the universe. This method is not without its disadvantages. It is very costly, costing up to several $billion, and would take a long time, up to years to complete and get results, which, if successful, would pave the way for groundbreaking discoveries. Some scientists believe that even if we are unable to catch up with Oumuamua, sooner or later, another object like it will wander into our solar system. What are your thoughts on this? Let us know in the comments if you enjoyed this video. Like the video and subscribe to our channel for more updates.